Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So today Brian is going to talk to us about some of their experiences of applying those tools to real-life code out there. Brian?
All right. So thank you, Ben. What I'm going to talk about today is joint work that I've done with Gary McGraw and Sammy Miguez from Cigital. And boy, am I loud now. Maybe I'm going to bump that down a little bit. Okay, maybe that'll work a little better for me. So it's really about, sort of in the broadest sense, advice and whose advice you ought to take. And there's no shortage of advice in the world. And if you think about all of the people who offer you advice, like your auto mechanic and your dentist and your doctor and Oprah and your mother, and if you tried to take all the advice that you were getting, then you probably wouldn't have any time to do anything that you wanted to do. And so that wouldn't be any good. And I'll tell you, when you get more specific and you start thinking about the security realm, there is absolutely no shortage of advice about security. So the question is, whose security advice should you take, and where in the heck did that security advice come from in the first place? And our assertion at this point is that a lot of that security advice was made up. And it was made up because there was no easy way over the last 10 years to know what you needed to do in order to build security into a piece of software. So people had to take their best guess and then go try some stuff. And we've now done that for long enough that we can go back and say, okay, what happened? And so this, we talk about the people who just sort of made advice up out of thin air as being the alchemists. And what we're trying to do here is say, maybe we're ready for a little bit of empiricism when it comes to building security into software, and we can go and look at what actually happened to people who took some of that advice, different pieces of advice, and figure out where they ended up. So, I use the language of revolutionaries at the top of this slide because, unfortunately, some of the content of this slide still is revolutionary to a lot of the world. We take it to be sort of the starting line. So things like you're not going to be able to get security right for a piece of software by sprinkling some cryptography on it. And you're not going to be able to get security right by adding in some sort of single mechanism that you hang over on this side of the software, and then it takes care of the whole problem for you, because software is an emergent property of the code. And if you're not with me on this stuff already, I don't really expect that you guys are going to have a problem with this. But some people do, and they're just not ready to talk about this stuff yet. So if basically the starting line here is people who are trying to build security into the code that they write. And the question is then, what's the right way to do that? What activities do you need to carry out as part of building a piece of software in order to be able to make some sort of case, or in order to sleep well at night? Maybe that's the easiest way to summarize it. All right, so here's where I'm coming at this thing from. I started out doing this kind of work, working in software security, because I liked sort of swinging around on other people's code like it was monkey bars and telling them stuff they didn't already know about the software that they were producing. And so I just liked it because it was fun. And so I advertise to people that maybe I can help them find vulnerabilities or protect their code against attack, or for the security evangelists, tell them maybe you could get some help from the people who are writing the software with getting security right, and sort of harness some of that developer horsepower and address the software security problem. But every time I make an assertion like this about some sort of interesting algorithm I've got or product that I've got to put a little asterisk by it that basically says, you can use what I just did in order to get better security, but you've got to use it as part of the bigger picture. In other words, you can't buy a product from Fortify and the moment you sign that check, now your security is better. You've got to apply it in the right way. Okay, that's I think, pretty easy to accept, but the question is then, what do you mean apply it in the right way? How exactly do I use this stuff? And so now I'm put in the position of being one of those people who has to give advice. Oof, okay, so what do you say? What do you say to somebody? Here's what I say to them. I say, there are a lot of good advice givers out there. Pick one. And the two big ones that I point out are generally McGraw and the stuff that he wrote down in software security, building security in, and then Howard and Lipner. And I like them both, and I like them for somewhat different reasons. Maybe I should start with Howard and Lipner. What I like is, here's a set of here's a software development lifecycle, and here are things you overlay on that software development lifecycle. And what's the real punchline here is, and we did it. We did it, and we know what happens when you do it, and we can point to the fact that we're happier now with our security than we were before because we did this stuff. But it's really easy for people to turn around and say, yeah, okay, maybe that works for you, Microsoft, but we don't do things the Microsoft way. So how do we know that any of this stuff is relevant to us? So what I like about McGraw is he comes by and he tries to do a much more generic version of a very similar thing, and in many ways comes out at a lot of the same points as looking at the Microsoft SDL. Everybody says you need to think about security before you start building stuff. You need to think about security as when you're designing the software. You need to think about security when you're implementing. And you need to swing all the way through the ball and make sure that you keep thinking about security once you've actually released a product or deployed some code. Right? So the OWASP guys have their CLASP methodology, and it does many of those same things. So if you step back a little way and you squint, you see actually a lot of the alchemy starts to kind of look the same, even though the breeds and stripes may not line up exactly. So basically, what I say to people is, you need to pick one of these, and then we can fit in a product or a technique into whatever methodology you choose. Okay, so that got me off the hook, quite honestly, for a good year or two. So not a bad one, but I started collecting questions that I wasn't answering so well, at least from my perspective. And here are some of them. So you say there are these steps that you need to carry out in order to build security into code. Are they the same steps no matter what piece of software I'm writing? Because I'll tell you, I've got the piece of software that is the flagship product for the company, and I've got the piece of software that allows me to display the cafeteria lunch menu to people who work in the building, and you're telling me I need to build those pieces of software the same way? That doesn't ring right, at least not at first blush. And then there's the question of how do I know any of this stuff is going to work? How do I convince internal stakeholders that they should give me budget or people to do any of this work? Can you prove it to me somehow? After that, it's like, okay, well, I bought it, I got things up and running, and I got some Fortify in there, and Fortify helped me find a bunch of vulnerabilities in my code. Do I have to fix them? Do I have to fix all of them? If I only have to fix some of them, which some of them do I have to fix? Hey, it turns out that I don't actually build all of my own code. I buy some code from some commercial vendors. I commission some of that code, and it gets written for me in India, and I bring it back. I just sort of point and click and download some of it off the internet in the form of open source. What the heck am I supposed to do with all of those different vectors that are bringing me code? I'll tell you, none of these questions for me were answered out of the books that I showed you on the previous page, which had some good fundamental ideas about how maybe security should be built into software, but don't really don't speak directly to any of these issues. And so my interest or my focus started to shift a little bit from this notion that what we need to do is build security into a development lifecycle. 2, we need to help people build a software security initiative. And when I say software, I mean anywhere that software comes from. And when I say initiative, I mean it's not something that you do over a release cycle. It's something that you do continuously and that accounts for the activities in the life cycle also. Okay, so I think that's the warm-up, and now we're back to the bulldozer. I guess I should have mentioned earlier on, you get to decide for yourself what you think the bulldozer is pushing around. But the survey, or the study that we did in order to try and answer some of these questions is called BESOM, and it's the Building Security and Maturity Model. We think it's the first real data collection from a fairly wide range of organizations about what their security practices are. Now, we sort of live, we security guys sort of inhabit an odd state where, historically speaking, people haven't been very willing to talk about what it is that they do, because they don't want to be caught out with tomorrow's vulnerability with people pointing at them and saying, you made some gambles and your gambles didn't pay off, so clearly you are negligent, right? I think that's sort of what drives people to be secretive about what they do with respect to security. So I think one of the things that's novel here is the degree to which people were willing to describe to us what they do. This really hasn't been, never has been, well, in the last 5 years or so, hasn't been much of an issue with Microsoft, where Microsoft has been very open about what they do from a security perspective. Not true for much of the rest of the world. I sprinkle URLs through a lot of the rest of this presentation, but they're all available off of the BESOM website. So don't scurry to write anything down. If you want to remember one URL, that's the place to go to get more information. All right, so when I say data collection, here's what I'm talking about. I'm talking about, instead of going in with a hypothesis about how software should, or how security should be built into software, we'll just go ask people who have been doing it. Because they haven't been sharing information to any great extent for a long time, in some sense they've been conducting largely independent experiments. And we'll look at where they've ended up in the same place and where to a certain extent they've diverged, sort of what they ended up without knowing it agreeing upon, and which questions aren't necessarily answered yet for them. So we did this first by creating a software security framework so that we could sort of structure a discussion and try and take this diverse set of initiatives and put them all on the same page. And then by conducting interviews with the people who are in charge of these initiatives. Now, you got to remember where I'm starting from. I'm starting from being a guy who likes to write software. And it turns out that in order to explain how to use my software, I'm ending up doing interviews with software executives and writing down those interviews and trying to sort of correlate them and coalesce them into some common sort of form. And I am feeling, at this point, quite out of my element. Feels much more to me like anthropology than it does like computer science. And all I guess I can say is I've tried to go where the work has taken me. I hope before long I'll get to return to my roots writing code, but this is what we thought needed to be done. Okay, so we performed these in-person interviews. We did not go down any sort of checklist. We did not go down any sort of a path where we lead someone to one answer or another. We would merely ask them to describe what it is they do in their organizations. Then we tried to take those interviews, slice them up, identify in them activities that were being carried out in these organizations, and then map those activities back to what we heard that the stakeholders were trying to achieve with them. So then we could map an objective to an activity. We came out of these 9 interviews with 110 different activities that we saw across 9 organizations. We then divided those 110 activities up into levels. That way we could say, we think this organization is more mature than this other organization when it comes to one particular breed of activity. And I'll explain more when I get to explaining the framework.
So you said
Please.
You studied successful organizations. What were your criteria for deciding an organization was successful?
So we chose organizations on two axes. One is that they had a significant dependence on software, So software was important to their business. This is fast disappearing as software becomes important to just about every business. So I think you can still argue that it's more important to some than to others. And second of all, that the organization was successful. This is a really, really important distinction, so I like that you kind of jumped right to it. So what's the right... we believe that security, for the most part, in most organizations, plays a supporting role. In other words, the organization has an objective. For the ones that we looked at here, they're all commercial, and they are almost all publicly traded, so their objective is actually written down in an SEC filing, and that is we're trying to give more money to our shareholders, right? And we're trying to look at if that security organization has at least done a good enough job in order to support the mission of the organization. This is not nearly as fine a point as you'd like to put on any piece of computer science work, and really does, to me, at least start to sound a little bit more like anthropology.
So, did you also take into consideration how important was the security of the software written by the organization? Like, for example, if Microsoft puts out a piece of software, then you may have tons of attackers trying to find loopholes in it, and because it's widely deployed. As opposed to, say, an organization that writes, say, embedded system software for your refrigerator, then it's not clear that you'd have the same number of attackers.
This is, I guess, my first point here, where there's the dependence of the organization on that software working well, and I'll give you a list of company names here where I think it makes sense. And not all these companies are exposed to the same degree. Microsoft is on the list, and I have a feeling you guys understand that exposure very well. Some of these companies are less exposed, but they move $1 trillion of transactions every day. So even a small problem to them can turn into a pretty bad one pretty quick, right?
Do you have examples of some companies failed because their security department did not do a good job?
You know, Adam, I should probably just let you rattle off the successes and failures here. But I mean, like, you can look at a company like Heartland, which is not out of the game yet, but is certainly significantly stung by one incident from late last year. You could look at ChoicePoint, another payment processor, who is out of the game.
Actually, they sold the company for more than it was worth the day before the incident happened. So I actually take a somewhat different position on this, which is that most companies that experience these sorts of problems don't go out of business. That the stock impact is actually very low, and there's some work by some folks at CMU that shows that. And the ones we know about, ChoicePoint, TJX, and then the two that actually did go out of business were Veris, a Bellevue-based medical information processor, and Card System Solutions, who had one of the first big credit card breaches. Mm-hmm. But that's a very, very small fraction of all of the software security failures, which raises some interesting questions.
I think your point is back to can you demonstrate this need to build security into the software? Right? I mean, it really goes back to that initial premise. We begin with the premise that we think it is critically important to build security into the software. As Adam is saying, if you just want to look at this from a stock price point of view, you can't necessarily support that easily. Look at a place like Microsoft, though, who has decided that it's worth investing significantly in security, and I don't have the time or patience to second guess that. So that's really kind of back to our premise. Okay, so let's see. I mentioned a software security framework, and I have to explain. This is the framework that we use, and I have to explain this framework. So if I can jump from anthropology to archaeology for a second, when the archaeologists arrive at a new site, they might use some string to sort of divide up their site into quadrants, just so that they can talk about what gets found where. And to a certain extent, that's exactly the same thing that we're doing with this software security framework, which is we just need a way to talk about a security initiative in some sort of a generic sense, so that we can compare very different software security initiatives. This is the framework that we chose to use. You're never going to find anything like this in nature. There's no right answer to how to structure an initiative, and there's no reason that you have to call the lower right-hand quadrant configuration management and vulnerability management, just like there's no particular reason why you have to take a particular spot on this spectrum and say, that is what we define to be red. But it's really, really important for us, from a communication standpoint, to just say, when I talk about red, what I mean is that, right? So this is the framework that we're using. We divide it up into 4 big domains and then put 3 practices in each of those domains. So from just to kind of quickly explain what we're talking about, we define that first domain to be governance, where we're talking about defining what it is you hope to achieve and how you're going to measure whether or not you achieved it or not. Compliance and policy, so trying to set up specifically what is it you're trying to get people to do, and then training, which is how you tell the rest of the organization what it is you expect from them. Intelligence, which might better be called knowledge. It's about all the things that you need to know about attack and defense in order to carry out your strategy. So we talk about attack models in there. We talk about what is it you want to incorporate into your design, and then standards and requirements, where you might say, we want to achieve a particular end. For our purposes, we're going to standardize on this approach to solving a particular kind of problem. And then SSDL touchpoints. Actually, when we got started on this, it was called SDL touchpoints. It was until we arrived here at Microsoft and started talking to you guys, and the word came back. We use the term SDL. If you call this SDL, you'll confuse the fact that we're participating in this with this name. You're trying to be generic. So we ended up having to make a term here to try and make it clear that we were non-aligned. So SSDL is software security development lifecycle. We're talking about things like you need to review the design. We call that architecture analysis. You need to review the code. We call that code review. And then you need to do some dynamic testing, which we call security testing. One of the things that was controversial early on when we were putting together this framework was the split between security testing and penetration testing. So when a lot of people get started at this kind of stuff, they might have somebody come in and try and beat up their code after they've put it in what they think is its final form. And that we think of as penetration testing. If it's after the fact, we call it penetration testing. If it's part of what you're trying to do in order to make sure you built what you intended to build, we call that security testing. Also out here in this deployment phase, we put software environment, and we also put in basically change processes. So configuration management, vulnerability management gets lumped down here. Now, if you go and you talk to guys who are interested in security from more of an operational perspective, they're like, whoa, my whole world is this. How can you put it in one little box down in the corner? And we say, hey, look, our focus is really on building the right stuff. We have to be able to interface with these processes, but it doesn't dominate our world. Okay, so here's my logo slide. This is where I get to put up 7 of the 9 companies that we looked at in the study. And I don't get to put up 2 of them. The 2 I don't get to put up are financial services companies who aren't as wild about having their name thrown around with respect to security. The one thing I guess I can say about them is they're both too big to fail. So the thing I guess that's important to note about this slide is there's some diversity here in terms of what these companies do, right? So there's Microsoft, and to a large extent, you guys have a finger in all pies, right? There's Google who approaches some slice of that. Adobe also, they basically are speculative producers of software. They think customers want something, they make it, they try to sell it to them. But then there's a very different bunch of companies here. Wells Fargo, these 2 guys who shall remain unnamed, who software is really completely secondary to their existence. They use software because it's efficient for running their business, but they don't try and sell a customer based on the fact that they've got good software. DTCC also falls in this camp. That's the Depository Trust Clearing Corporation. So they're basically the back end for a lot of Wall Street. You perform a trade, it goes to your broker. The broker is going to eventually flow that transaction through DTCC on the way to reconciling it with whoever you traded with. These guys inhabit a very, very different world from a regulatory perspective. And that is, they've got government auditors, and more government auditors this year than last year, in their business, looking at the way they do things. So not only is software sort of secondary to them, but they've got a lot more constraints on how they operate their business than everybody who's represented here from the West Coast sort of does. All right, so along the way, we ended up almost accidentally collecting this is all information we collected usually in the first 5 minutes of an interview. Just sort of tell us a little bit about you, sort of a thing. How long have you been at it? How long has there been a software security initiative in your organization? Oldest one we studied was 10 years. Youngest was about 2.5. On average, these guys have been at it for about 5 years. We hope that means that many of these organizations have tried some experiments and, to a certain extent, found some things that work and some things that don't work. They have done a little bit of evolution already when it comes to security practices. But again, we didn't test that. We were just asking them about the state that they're in today. Adam.
You say the newest is 2.5 years old. Is that because you excluded newer programs? They weren't willing to talk yet? You're not aware of new programs being spun up?
We took, let's see, boy, how long was our initial list? Our initial list was about 35 organizations who we think are doing something substantial in this domain. And that's just from the network of security people that we know. We know about roughly 35 big ones. We contacted 10 of them and asked them, because we thought they were fit our criteria pretty well. We got 9 accepts out of 10, so 9 people who were willing to talk to us, 7 of which would allow us to use their names. And that's how we chose our sample set. So we did not sort of prejudge those programs to a great degree, although clearly we are starting with the universe we are aware of to study.
So when you went and approached these companies, what did you tell them this data would be used for? Because if somebody came and told me, I'm going to say publicize this information, I may try to exaggerate the amount of security testing in the organization or how long I had the security program, right? So I'm just curious about the social factor.
So there's you ask somebody for something. I might say, hey, can I have $1? Or I might say, hey, will you spend 2 hours talking to me, right? But still, you have to give something up. And what are you going to get in return? And the promise to these organizations in return was that we would give them a detailed rundown about where they sat with respect to the other companies we were studying. And I'll get back to this towards the end of the presentation, but that turned out to be a more powerful lure than I knew it was going to be going in. Partially because the people in charge of these initiatives have a real problem when they explain what they do to people outside the security organization. Measuring success is very, very difficult. And so being able to know what you're doing compared to your peers in other organizations is powerful.
I have a clarification question. When you say the security initiative inside Wells Fargo, you're talking about the people inside Wells Fargo develop their in-house software and trying to make their in-house software secure, or they want to check the software they buy from other software vendors are secure for their purpose?
The group that I'm talking about at Wells Fargo is responsible for both of those things, and they're specifically responsible for the business that Wells Fargo conducts on the internet. Okay, so now, so we've talked about the age of the initiative. Next, we can talk about how many people do they have doing this stuff. On average, the average size of the SSG, or the software security group, was 41. The smallest one we looked at had a group size of 12. The biggest was 100. Let's see. I'll come back to a little bit of software security group size here in just a minute. One thing that we noted pretty early on, after we'd done about 3 interviews, is that everybody was telling us, well, we've got this group of people, this software security group, and they have security on their business card, right? Because they do security. They're security professionals. But there are all of these other people out there who don't have security on their business card, but we rely on them. And they end up doing a fair amount of security-related stuff. A lot of times they're embedded in product groups or business units. And they really help us out a lot. We eventually saw enough of this that we gave it a name. We called it the satellite. You could think of it as sort of the extended software security group. And not everybody has one. So the smallest here is size 0. Some people have really elaborate systems set up to try and nurture sort of a set of security aficionados in the organization, and that becomes that software security group. Okay, so the last quadrant here is the size of the development organization. This gives you an idea about how big these places were. Largest, 30,000 people writing code. Guess who that is? Smallest organization that we studied had 450 people working on software development. The average was more in the thousands, or 5,000 neighborhood. There's a really important, so 3 orders of magnitude here, right? Hundreds of developers, thousands of developers, tens of thousands of developers. There's one really important data point left off of there, and that's the organizations where all your software developers can still fit in your garage, right? So how do you do a good job of building software when you are itty bitty? How do you do a good job of building security into your code when you're one guy trying to write an iPhone app and get rich $2.99 at a time? We don't have any idea about what to tell you about that kind of stuff. We absolutely just didn't try and study it. It to a certain extent breaks our model, where we're going to try and take successful organizations and study them, because an organization, if they're itty bitty, perhaps is not successful either because they're never going to be successful, or because they haven't had long enough to be successful yet, and then we don't know how to study them. So one of the valid criticisms I heard here is, well, hey, I've got 100 people in the entire company. What can I learn from this? And I think you have to do some significant reading between the lines, because we can't give you any direct information about that.
What's missing the line is like open source companies, right? They write a lot of code to share with others. They use a lot of open source code, and how they manage their software could be very different from like a Microsoft.
And is quite different, and they've got a different set of problems. There are a lot of things missing from here, though. Government and military organizations, didn't study them. They've got their objectives usually aren't quite so crisply defined as return value to shareholders, right? So they're a little bit, again, they cause us trouble with defining success, and they don't necessarily behave the same way as people who build quite a bit of their own software.
Also, with the exception of Wells Fargo, it looks like all of these are product companies. So they sell software as a product, but you also have custom or companies that do consulting and create a software solution that's specific for a business need.
So the two companies that I didn't name are most equivalent to Wells Fargo when you look at that slide. If you look at EMC, while they do sell a lot of product, they do sell software products. They also sell quite a bit of software embedded in big systems. Let's see, DTCC also falls into that Wells Fargo camp. QUALCOMM is an interesting one, where the primary product is hardware, not software, but it takes quite a bit of software in order to make that hardware do what you want it to do. So then you can also look at a company like Google, where you may be paying them, but you're not paying them for something you go install on your computer for the most part, right? So we did get a fair amount of diversity here. I think kind of where this conversation is going is 9 data points ain't a whole hell of a lot. And that's absolutely true. This data is a fairly hard one, though, and so we're going to end up building up this pile a little bit at a time. Okay, so here's a list of 10 things that kind of surprised us coming out of this. And I don't think I'm going to go through this list point by point, but we could certainly pick things here that you guys would like to talk about. Maybe I'll pick one or two in order to maybe get started. I like this one a lot, evangelize over audit. So you might think that in a very technology-driven organization where you ship the software, that the security people were going to have to kind of be evangelists. They were going to have to win over developers with rational arguments about why we're better off with security than we would be without security. Right? However, if you go to a place like Wells Fargo, you might think, you guys are used to living in a regulated environment, and you're going to do security because I say so. And the security team would, for the most part, wield the stick rather than the carrot. And we did not see that. We very uniformly saw that the carrot is the winner. So that's evangelize over audit. WAFs are web application firewalls. You guys generally familiar with web application firewalls? So this whole notion that instead of a firewall which might not allow traffic through on certain ports or under certain conditions, the idea is we're going to do the same thing to purely web traffic and say that HTTP request looks like an attack and therefore I'm not going to allow it through, that sort of thing. What we saw is that nobody we studied is using them. Some of them own them though, but they don't use them as firewalls. They don't use them to decide which requests to service or not. They use them in order to try and understand better how their websites are being attacked. So that was noteworthy to me.
If you ask the Microsoft security people who do the software secure software development lifecycle, I bet they wouldn't know if Microsoft.com use web access firewall, web application firewall.
So here's the thing.
How do you know this?
We're studying organizations that are between big and really big. If you want to ask them about something that they do you always do a design review? Well, the answer is no. There's nothing that happens uniformly, absolutely 100% consistently in a large organization, right? And there's no one person who knows all of the things that happen in a large organization. What we're looking for here are what are the big picture items, right? We're never going to be able to do a study like this or understand common practices down to individual lines of code. We've got to look for what are the big trends. Right? So certainly, if it was the typical practice that you do not deploy an application on MSN unless it was a web application firewall, believe me, Steve Lipner would know it, right? And that's the level of resolution of the data that we've got here.
What is number 2? Secure by default.
Secure by default frameworks. Okay, so I'll tell you a little bit about where I come from at Fortify. So Fortify makes these products, and the products help people find vulnerabilities in their code or suggest ways that they might make their code more robust. And so that's sort of the way I come at software security. Well, it turns out that in these software security groups, there are a fair number of people who have that kind of audit role, or they're helping people to audit, or they're doing audit kinds of stuff. But there's a second side to these groups where instead of trying to sort of point out weaknesses, they're trying to help people do the right thing the first time around. That might be by educating them, but it's also by just giving them a piece of code that does the right thing. It makes the audit guy's job a ton easier, because when they come across their own code, they're like, we already know how this thing operates, and we know to what extent we trust it. But everybody is building code and shipping it into their product units and having those product units make use of it. And that's something I didn't know was as extensive as it is, which is how it made its way onto this list. So again, these are not all of the things that we learned. These are the things that I kind of went, I wouldn't have guessed that. And the reason why that's important to me is because if you look at sort of the alchemist approach to doing software security, where you sort of write down all of the things that kind of make sense to you, you don't necessarily end up in the same spot as if you just go ask people, what do you do? Anybody want to pick something else off of here? Ben?
I was going to ask about sort of if you could comment on market forces behind essentially 3, 9, and 10. So pen testing down, fuzz up.
Let's see, 3, 9, and 10. Okay. So, I don't know. This seems to be this web application firewall business seems to be at least moderately successful. There are still a number of vendors. They seem to be heading kind of down the same path that everybody heads down when they try and put a new box on your network, and that is eventually sort of Cisco swallows you, right? And that seems to be moving right along. So, I mean, it's not like a runaway hit like the original firewall was, but it doesn't seem slated to disappear either. Let's see, you pointed towards 9. The story in 9 is I think, a good one. So here's sort of my mental image for how a lot of these software security initiatives get started is something happens. Maybe somebody has a bad dream. Maybe they've got a big security incident or a series of security incidents occurs. They say, it looks like software might be kind of a weak spot for us. Maybe we need to think about software in the context of security. What do we do first? Well, do we really have a problem? I mean, it seems like everybody else has a problem, but do we have a problem? Why don't we go hire some people and they'll try and break into the system and we'll find out whether that problem is real or not. Guess what happens when you haven't been thinking about security too much and some people try to break into your system? It works, right? So all of a sudden there are these guys, these penetration testers who broke into your system and can tell you the different ways that they can prove that you are weak. Then you go back and they're like, hair on fire, got to get that stuff fixed. Okay, you get that stuff fixed. You have the penetration testers come back in and you're like, we took care of that. What happens? Penetration testers break in again. And then you start being like, why didn't they tell us about that stuff the first time? And the fact is they might have had to work a little harder the second time around. But the fact is you were sort of painting the room with the lights off. Then you turn on the lights and you find out that the room isn't painted the way you'd like it to be. And these guys can go many, many rounds breaking into your system until you get tired of this game. And you say, hey, I think we need to start thinking about building the security in the first place so that when we get around to taking the test, we pass it. What happens then is they put less emphasis on this penetration testing. They're no longer relying on these penetration testers to tell them what's wrong with their code. The second interesting thing here, and I'll have to do it pretty quickly, but these penetration testers never go away. So the interest in penetration testers diminishes, but this outside reflection, or this outside opinion about, okay, did we build something that's good enough, seems to be one that hangs around. So interest goes down, but it does not disappear. And then you pointed to 10. Everybody's fuzzing. And almost everybody is not like just downloading some fuzzing toolkit from the internet and kind of pressing go. They're putting some thought into how do they fuzz their APIs, and they're doing good stuff. It hasn't been a big commercial success because nobody's figured out how do you, a fuzzer is a pretty easy thing to write version 1.0 of, right? But it's not necessarily such an easy thing to make it really, really work well in the environment of a particular company. And nobody's cracked the code, I think, from a commercial standpoint on how to make that go. That cover what you're after, Ben? Okay. All right, so if you go and you take a look at the BESOM, this is one of 12 skeleton pages where we outline here all of the activities related to training. So we list the activity over here, the objective that people are trying to accomplish by conducting the activity over here, and then over on this side, we just number the activities level 1 here, level 2 here, and level 3 here. So for each one of these activities, we wrote a paragraph that describes the activity. In this particular case, so the idea is that Software Security Group has office hours. You can pretty quickly, you can see how this is an advocacy activity, right? when people just have to do what you say they have to do, they can go read the manual, right? They can go read the rules and regulations, and you don't ever have to talk to them until it's time to take the test. But when you're an advocate, you make yourself available for anybody who's got any kind of security question that you want to talk about to come in and talk to you about it, right? So at the end of every one of these paragraphs where we describe this activity, we gave an example. And the example here is office hours held one afternoon per week in the office of a senior software security group member. Clearly, that's not the only way you could satisfy this activity, but it's the one. But we give an example here, and every example we gave is real. In other words, one of those 9 organizations does this office hour activity this way. The idea is to try and give people a suggestion about how they might go about doing this, and try and take this this abstracted view that we've built of these 9 organizations, and tie it to a real way that activity is carried out in at least one place. I particularly like this activity because it's one that Fortify invented on its own too. So our research group ends up partitioning its time such that if you want to come in, if you work at Fortify and you want to ask a security question to a researcher, you've got 2 times a week you can come in, and you know somebody will be there ready to talk to you. Okay, so you take all of those activities, you take a bit vector that describes everything that an organization does, and then you can give them a scorecard. So we take the 12 different practices, and then we take and then we measure the organization. And we really struggled with, how do you measure an organization? How am I going to say whether Microsoft's training work is a 2 or a 3? Right? How would you say that? Well, we looked at a lot of different ways to do it, and eventually what we found is that a high watermark was just about as good as anything else. By high watermark, I mean if on our list of activities we observed one activity at level 3 for an organization, we called that organization a level 3. You could, theoretically, not do any level 1 activities, any level 2 activities, just do a level 3 activity, and you're there. Now, that's a fairly low resolution approach to trying to give someone a score. For the data set that we had, it came out just about as well as trying to do an average or a weighted average of the numbers. And it was really simple to compute. So it's easy to explain, it's easy to compute. That's the information I'm presenting here. So then what you can do is you can take an individual organization, represented here in blue, and overlay it on the average, represented here in red, and you can give people a quick sort of take on how do they compare to the average over the study set that we had. People really dig this stuff. I remember kind of graduating from high school and thinking that I was sort of happy to de-emphasize the report cards in my life, you know. But apparently, at some point, people get around to missing them. I'm going to jump forward and show the expanded version of that report card here, and then I'll go back to the previous slide. So here's the detail on that scorecard, and I have to do quite a bit of unpacking to try and explain what we're representing here. So maybe I should say this first. We observed a set of 10 activities that everybody does, and my definition of everybody here is a little bit liberal. When I say everybody, I mean 8 of the organizations we studied or 9 of the organizations we studied. So we gave ourselves just a little bit of leeway when we defined everybody. So the things in green here are things where this hypothetical organization did one of the activities everybody does, right? So green is good. Maybe I should explain this chart a little bit better. So every one of the 110 activities is listed. So like here, here's the training section down here. Then the next column is how many of the 9 organizations carried out each of those activities. And then this column right here is the particular organization that this report card is for, right? So you can see 9 out of 9 organizations did training 1.1. And because 9 out of 9 did it, of course, this organization did it too. So that's in green. In red are the things where everybody else does it, but you don't, right? So let's see, when we find one in red. Here, I'll pick that, architecture analysis 1.3. 8 out of 9 organizations did it. This organization didn't do it. So, okay, so what does it mean if everybody else does it and you don't do it? I can think of two things that it might mean.
Well, what does it mean if really everyone does it and you don't?
So like for instance here, if you see like a 9 here, but there's a red square here, that's because this data is made up. We wanted to show a representative scorecard without showing anybody in particular's scorecard. So what does it mean if everybody else does it and you don't do it? It might mean that you are, I don't know, pick your favorite synonym for negligent, right? So you're just not very good, right? Or it might mean you're so sophisticated you don't need to do that anymore, right? And it could. We don't know. We don't know what it means. We think it's probably interesting for that organization to understand, though. So red things are things that you probably need to understand. Okay, so other than we've covered green, we've covered red, now we should cover blue. So I showed earlier a chart where I was comparing the average in red to blue, which represented that particular company. If you were below average in a particular area, then we picked out a few activities that would bring you up to average or take you beyond average. And we did that purely based on the prevalence of those activities in the data. So for instance, here, the strategy and metrics is, this column is kind of shaded blue because they're behind, the organization is behind average, but hey, SM 2.1, 7 out of 9 organizations did it. Maybe that's something you'd like to think about because it seems that a lot of people do it and it would at least take you up to average in that area, right? So purely analytically driven suggestions about the kinds of activities that you might want to consider is what we get out of the blue. Let's see in the back.
Do you have a plan to talk to these 9 organizations? Will you give them this scorecard, try to understand why they didn't do this rat things?
So this in fact was the promise that we made them when we went in and gathered the data, was that we would come back around, give them these scorecards, and talk them through them. Now, we can tell them what strategy and metrics 2.1 is and how we define that. To go in and try and to help them to get there is beyond our abilities to do as part of a study. We think that people got a lot, or at least were very interested in seeing these scorecards and comparing themselves. What they're doing with the information, I don't know. Our intention is to go back to them after a year and find out what's changed. So we hope to get a little bit of information there, but you can't really get it instantly.
So if you're doing something just because everyone is doing that, why is that necessarily a good thing? I mean, you could be just going through the motions without actually investing in that process, right? So I'm curious about why you assigned green equals good.
Well, I think that the larger version of that question is effectiveness. In other words, maybe everybody is doing it. Everybody is doing a particular activity the same way everybody has an appendix. Like they've got it, but it's not clear what exactly it's doing for them. We're trying to really set ourselves apart from the alchemists here, in that we're trying to study what people are doing, but not necessarily make a value judgment about whether that's an effective activity or whether that's something that they need to be doing or not. So maybe these good and bad here is a place where I've stepped over the line trying to label these. I should say you're running with the pack and you're not running with the pack. Right? I think that would be a better representation.
So your premise seems to be more is always better here, which I agree is a good premise if your goal is to build software security organizations or software security groups. If your goal is to maximize profitability, that executive from Wells Fargo would look at this and say, here's all the things I'm doing that most other people aren't. We should cut those out of our budget because it's not necessary. So how do you make the case of, if you're doing things that other people aren't, should you be?
So there are two things that I would emphasize here. One, let's see, what's the right way to come at this? One way to get a perfect score here would be to do everything. You do 110 activities, therefore you get a perfect score. But you might remember, according to our scoring system, all you have to do is one activity at level 3 in order to be graded at a level 3. Therefore, the least expensive way to get a perfect score here would be to do 12 things and to just pick those 12 things from the level 3 activities. Right? We're not trying to come up with a system here that can't be gamed. We're trying to come up here with a good way to describe what we saw. Right? So, we went out into the jungle and we saw monkeys eating bananas. And is that a good thing or a bad thing? Or is there a better way for those monkeys to eat the bananas? I don't know. Now we might be able to take this data and get there someday, but it's certainly not what we're after here.
I think that most of the organizations that are making this investment believe they have a business reason to be doing it. But what's really interesting to me is that, let's say you're an organization who is getting started doing this, you can actually start to use this to say, these are the things that everybody does. It's reasonable to think that if everybody is doing it, they probably have found value out of it. Doesn't necessarily mean you will, but organizations really struggle hard with, how do I start? And I think that's one of the huge values of this being public is you can look to the green items, you can look to the 9s and say, nobody who is doing this doesn't bother to invest in that thing.
I think that's not the way people. I think it's easier for you to say that than it is for me, Adam. I think that's exactly right because you're starting to put value on those things and say, hey, people invest in this stuff because they find it useful. But it's possible that it was useful at one point and they kept doing it past when it was useful. Don't know. So I list here. I'm not going to be able to talk about this because we're over time now. So I'm going to try and wind up here in just a minute or two. But we list the 10 things that everybody does. I'll tell you. Everybody does good network and host security. It's if you can't install a web server and get it up and running right, if you don't have a reliable way to put a new host on the network, you probably don't need to be thinking about this stuff yet, right? So there are more interesting things in here. Evangelism comes up again. A lot of organizations think that training is one of the most critical things that they do when it comes to software security. They all roll their own history into the training, so it's not like buffer overflow is bad. It's more like, let us tell you about where we've been burned on buffer overflow before, right?
Static analysis is one of the bullets there. So can you comment a little about that? Are they using tools that are in-house or standard tools that you can buy from Spotify or Community?
They use tools. They use a combination of tools that they've built themselves, that they've bought commercially. Let's see. There's not one right answer for skinning that one. What is clear is that doing code review, you need to do code review, and you don't want to do it all with eyeballs. Okay, so let's see. This seems to be like one of these topics that was sort of, to a certain extent, in the water. And if we didn't publish about it, somebody was going to publish about it sooner or later. So I wanted to point out a couple of other things that sort of tend towards maturity model that are in the mix. There's the software assurance maturity model, SAM, also known as OpenSAM, which actually was the precursor to the BESOM work. So I hired Prabir Chandra to create this. We basically were doing a little bit more alchemy, and we looked at it when it was done, and we said, "Oh gosh, we're a little dissatisfied with the idea that we just sort of aggregated a set of good ideas. Let's go out and try and study some stuff." But we'd shown that project around to enough people. The OWASP crowd had kind of latched onto it, so it's out there. And I don't think it hurts anything, but I don't think it's particularly revolutionary either. We found out when we were about halfway through with this work about the Microsoft SDL optimization model, which is, of course, the way that you take the Microsoft SDL and kind of try and build a little bit bigger, build more of an initiative rather than trying to think about the SDL as a static kind of a beast. We think that we're providing data that could power just about any model. So we publish, as part of the BESOM report, how many times we observed each of these activities. And if you don't like the way we ranked these activities, if you don't like the fact that we left a couple of things off, you can still use our data set. And we hope people do use our data set to support other hypotheses. All right, so I'll put the URL up there one last time. I'll make just a few closing comments about the BESOM work. We think it's useful as a yardstick. We think it's useful for people to figure out, to measure their own initiative. We think it's useful maybe to start looking around and thinking about what you might want to change about your initiative. We think, though, as a yardstick and as something we put out there under a Creative Commons license, some people are going to take that yardstick and they're going to crack it up and roast a hot dog with it. And that's okay. I think that's the kind of price you pay when you decide to start trying to do some of this stuff in the open, rather than just say, oh, I heard about a company that did this once and I think that'd be a good idea for you. You got to expect some abuse along the way, and we're okay with that. We're trying really hard, though, to get away from this world of alchemy where people mostly win with either the credentials they put behind their name or with the forcefulness of their rhetoric, and trying to start to base some of this stuff on principles that look a little bit more like science. We don't think that we're ever going to get to a point where there's a right way to do software security. So we looked at a lot of organizations. They've got a lot of different forces acting on them. What's interesting is when those lot of different forces drive them all to doing some of the most similar things. So I think that list of 10 common things is a really powerful outcome from this work. However, we don't expect we'll get to a point where we're ever going to give you a formula or a recipe for here's what your organization has to do. I'm pretty well over time, but I'm happy to hang around here for a while after the presentation if you guys want to continue the discussion. Thanks for your attention.
Are you convinced that what you have outlined here is enough of a recipe to get organizations to change their practices, or do you think there needs to be other stuff that needs to be done in this space?
So I think there's an initial decision where you choose to invest seriously in building more secure software, and we're not really building the case for that. Once you have made that decision, what should you do first? What should you do after that? Those are the kinds of questions that we've addressed. There are a couple of things we've already discussed in this hour where I think we're weak, and that is 9 data points is not enough. And I think we don't really have any advice for people at the low end. Security people are just famous. Like you call them up and you're like, I got a security problem. And they're like, you need to have called me yesterday, right? The security guys always say that. And yet we can't talk to the smaller organizations yet, and we need to find some sort of a way to address that. So I think there's a lot more we can do in terms of filling in this picture. I'm reasonably happy with the high-level outline that we've built. I don't think we'll ever stop.
In terms of the methodology, so you're happy with the methodology, you're just saying you need more data points.
Well, we get to this methodology question we don't know how to answer yet, which is how do you judge success in a small organization? So I don't think we've answered that yet. And I wasn't trained to be an anthropologist, so I'm quite willing to believe that I've got a lot to learn there. Although I hope that we've got useful stuff in this first round. I'm sure there's plenty more we can do to make that better. If you've got ideas, I'd love to hear about them. Adam, were you up next?
Sure. I have 2 questions, and they're sort of related, which is, have you studied failure either at the organizational or activity level? Like, what activities have people stopped doing? And are there orgs that tried to do this, didn't succeed, and can we learn something from those?
One of the things that came out of this work that isn't really represented in this presentation is a long, long list of anecdotes. And we chose early on when we started sifting through our data to try and concentrate on what people were doing today and what they presented in a way that led us to believe they were going to continue to do it. Along the way, we got a bunch of interesting information about stuff that they had either stopped doing or just horror stories. Because, you sit down with a security guy, before long, we're talking horror stories, right? So, for instance, we talked to a number of people who really felt like they'd been burned by bad metrics. So they knew they had to measure, because you work in a big company, you're going to have to measure something, especially in the security realm where, not being broken into tomorrow doesn't necessarily mean anything, right? They had put metrics in place that they thought did the right thing. They'd found people were changing their behavior because they knew about the metric, but they weren't getting the behavior they wanted out of them. And let's see, let me think of other failure cases. That's the one that immediately jumps to mind. I've got a file full of these things that I'm still trying to figure out how to present.
Just a comment. I think a piece of data that can be interesting to study is how these organizations reward this kind of effort. For example, if you have security problems, do you penalize the security people or penalize the developer who generate, who produce these vulnerabilities? So I think that seems to be interesting and relevant to this.
The reward system. I'll give you just another anecdote there. So here's my favorite reward system trick that I learned as part of this work. So you remember the security group has this sort of extended circle of people that they work with, right? So here's what the guy in charge of the security organization does. It comes around to reviews, and it's time at the time in the year where we're doing reviews and raises. Well, the guy in charge of security takes his favorite 10 developers who've done the best job for him and writes a lengthy and glowing praise letter for them and makes sure that it gets to the desk of the manager of that person. And what he finds is, over a period of years, people who do better at security tend to get promoted, and they tend to have more power in the organization, and this feeds very nicely on what the director of security wants. So, I mean, there's an example where the security guy is trying to affect the reward system. We saw very, very inconsistent data about training, about whether or not people track, whether or not the organization has been trained. Some of them can say, there was a point in 2005 where all developers had been trained. And now, we don't know. We just don't know anything about who's been trained and who hasn't. And so there's a place where they're kind of inconsistent about it. I think you're right. You could. I can tell you, I didn't see any instances where the beatdown really hits the security guys when there's an incident. Didn't hear that from anybody who felt like they were going to have the rug pulled out from them in terms of organizational power on the next incident. Nobody represented that.
The mindset of developers is important. Do I, as a developer, own the security, or the other department, which is the security department, own the security of my software, of my code? This can be very important.
For the most part, I think the organizations we're looking at are kind of over that, and it's very, very. You can push this analogy too hard, but you can think about software quality kind of in the same vein, where you say, who's responsible for quality? It is certainly not the person who's trying to measure quality, right? Dave?
So I'm going to ask a question that may sound a little bit hostile, so I want to preface it by saying I really like this work and think it's very useful, but I think a more appropriate title would be the beginning of alchemy, not the end of alchemy. That this is really getting us from the pre-alchemy stage to the alchemy stage, where where people are starting to share information, you're learning what other people are doing. We don't have sort of scientific understanding of the fundamental limits or ways of measuring things. And if goal is to go beyond alchemy to get to something empirical, which is what you're claiming, we would need ways of actually measuring how well things actually work, not just understanding what people do.
Effectiveness. This comes down to I think it comes back to the effectiveness thing. So like, okay, you did static analysis. Well, is that actually doing anything for you, or did you do it because it's some sort of popularity contest? Right. I mean, I think you're absolutely right in that. This is not going to be the only sort of metric that you might measure an organization by, and it does not directly address this question of effectiveness. I think, though, well, maybe this is part of your point too. I think, though, that just like Lord Kelvin, like basically, he just started kind of making some tick marks on the glass and measuring where the mercury was. And those tick marks didn't really mean anything in and of themselves, even though now we call them degrees and we find them very useful. Is to start kind of coming up with this common vocabulary for talking about this kind of stuff is the starting line for science, which I'd want to divide from alchemy.
So they're going to be security violations of the third degree. Right. So let's thank Brian again.